How many protons, neutrons, and electrons, respectively, are present in the element? The options are given below. Before answering this question, we have to understand one thing: nuclear notation. Nuclear notation. If we have an unknown element, let's call that unknown element x. A number is always attached at this point, which is A, denoted with capital letter A, another number denoted with letter Z. X is an unknown element, whereas A is called the mass number. A is equal to mass number, and Z is equal to the atomic number. So if we are comparing this with what is given to us, what we have on the board is C. At this point of A, we have 60. At this point of 27, at this point of Z, rather, we have 27. Let us compare this element to this nuclear notation. In this nuclear notation, A represents 60. A is equal to 60, which is the mass number, and Z represents 27, which is the atomic number. Atomic number is 27. What is atomic number? Atomic number is the number of protons present in the nucleus of an atom. So atomic number is equal to number of protons. So we have that the proton is 27, which is the atomic number. So proton is 27. Because the element is neutral, it is neither positive nor negative. Since the element is neutral, we can also say that the number of protons is equal to the number of electrons. So the proton number is equal to number of electrons. So in the electrons, we have electrons is equal to 27. Now mass number is equal to atomic number plus number of neutron To determine the number of neutrons, we must make neutron the subject of the formula. So neutron is equal to mass number minus atomic number. Mass number minus atomic number, and that is equal to the mass number is given as 60 minus the atomic number is 27. This is equal to 60 minus 27 gives 33. So the number of neutron is equal to 33. Okay, from the board it was given as proton, neutron, and electrons. So proton P is equal to 27, neutron N is equal to 33 and electrons E is equal to 27 respectively. So let's examine the right option on the board. 27, 33, 27. 27, 33, 27. So the correct answer is C. The radioactive radiation used in studying the arrangement of particles in giant organic molecules is dash. Option A, gamma rays. Option B, alpha particles. Option C, X-rays. Option D, beta particles. Now note this, to study the internal arrangement of atoms in large molecules, scientists used what is called X-rays. This is because X-rays have short wavelengths, and short wavelengths can be used to detect small atomic distances. That makes it suitable for complex and large molecules. So the correct option on the board is option C. X-rays is used for radioactive radiation. Water is said to be temporarily hard when it contains. Options are given below. Temporary hardness of water is a type of hardness that is caused by dissolved bicarbonate of magnesium and calcium, and this can be removed by boiling. So the correct option on the board is option A. Option A. On exposure to the atmosphere, a hydrated salt loses its water of crystallization to become an hydrox. The phenomenon is referred to as dash. The options are given below. Let's examine each of the respective options. A fluorescent compound, these are the compounds when exposed to the atmosphere, they will lose part or all of their water of crystallization to form a solution. So the correct option is efflorescence. The liquescents, when exposed to the atmosphere, they will form a solution. While hygroscopic, when exposed to the atmosphere, they will not form a solution but become sticky. So the correct option is efflorescence. Efflorescence compound. Take note, to remember these three people, 1, 2, and 3, is that the first one talks about water of crystallization, whereas the second one forms solution when exposed, and the third one doesn't form solution when exposed to the atmosphere. So take note of the concepts. 16.55 grams of lead-2-trioxonitrate was dissolved in 100 grams of distilled water at 20 degrees Celsius. Calculate the solubility of the solute in mole per dm cube. The parameters are given and options are also given below. Now in this question, solubility is equal to number of mole of solute, it is in mole, divided by volume of solvent, and it is given in liter or in dm cube. Right here on the board, the first thing that we have to determine is the number of solute from the question given. So the solute in the question is lead-2-trioxonitrate. And to determine the number of mole of solute, we have to write down the correct chemical formula for lead-2-trioxonitrate, which is Pb in parentheses NO3 2. To determine the number of mole of lead-2-trioxonitrate, number of mole is equal to reacting mass It is in gram divided by the molar mass. Molar mass of the compound in gram per mole. In gram per mole. To get the molar mass of the compound, Pb in parentheses NO3 2. We add all the elements in the given compound first. That is Pb plus, in bracket, nitrogen N plus oxygen O subscript 3 times 2 times 2. This becomes, lead is given as 207. The atomic mass of lead is 207. That of nitrogen is 14. Plus, and oxygen is given as 16 times the subscript, which is 3 times 2. We have 207 in the bracket. 16 times 3 is 48, and 14 plus 48 is 62. So we have plus 62 times these 2. Now take note of this. From the compound given, lead 2 triazonitrate 5, the bracket has a subscript of 2. That is to say, we are going to multiply the value obtained in the bracket by 2. So we have 207 plus 62 is 124. 207 plus 124 gives 331. 331 gram per mole of lead 2 triazonitrate 5. So from this formula, number of mole is equal to reacting mass over molar mass. We can get the number of mole. At this point, the molar mass of lead 2 triazonitrate 5 has been determined to be 331 gram per mole. We can get the number of mole of the compound. So number of mole is equal to reacting mass all over molar mass. And reacting mass is in grams. The question on the board, reacting mass is given as 16.55 grams. So we have 16.55 grams divided by molar mass, and the molar mass is given as 331 gram per mole. So this divided by this is going to give 0.05 mole. 0.05 mole. At this point, we have successfully determined the number of mole of the solute, which is lead 2 triazonitrate 5. So solubility equals the number of mole, and the number of mole of the solute is known. The next thing is to determine the volume of the solvent. So the number of mole of the solute is 0.05 moles. 0.05 mole. Then the volume of solute is equal to mass of solute all divided by density of water. So mass of solute from the question is given as 100 grams of distilled water. So the mass is 100 grams divided by the density of water is given in parentheses as 1000. So we have 1000. If you divide 100 by 1000, it's going to yield 0.01 liter in liter or in dm3. Liter and dm3 are basically the same thing. So at this point, you are going to determine the solubility. Solubility is equal to the number of mole of solute, and it was given as 0.05 mole divided by the volume of solvent in liter. The volume of solvent is 0.01 dm cube or in liter. So 0.05 divided by 0.01 is 0.50 mole per dm cube. So the correct option is option D. Option D, 0.5 mole per dm cube. The basicity of CH3COOH is dash. Option A 4, B 1, C 2, and D 3. In this formula, we have the alkyl group and we have the carbonyl group. So this person is called the alkyl group and this is the carbonyl group. So this is the alkyl group and this is the carbonyl group. In carboxylic acid, the acidic hydrogen is always attached to the carbonyl group and never to the alkyl group. What is basicity of an acid? Basicity of an acid is the number of replaceable hydrogen ion present in one molecule of an acid. So, since the acidic hydrogen is attached to COOH, then during chemical reaction, this COOH is going to be removed and we will obtain COO minus. So the basicity of the acid is 1. The basicity of the acid is 1 since one hydrogen is going to be replaced. The color of litmus in a neutral medium is dash. Option A purple, B pink, C yellow, and D orange. Litmus paper is an acid-base indicator. It changes color depending on the medium. Okay, if the medium in acidic medium, the color of litmus is red. In basic or alkaline medium, the color of litmus paper is blue. Then in neutral medium, the color of litmus is purple. So the correct option on the board is option A, purple.